everybody. My name is Isaac Montoya, and I am the Director of Marketing here at Upside Technologies. I would like to thank you all for joining us here today for week 2 of our 7th annual Airflow Management Awareness Month. For those of you who don't know, we started Airflow Management Awareness Month back in 2015 with the intention to not only raise awareness around airflow management, but also around cooling optimization, thermal efficiency, and overall data center best practices. We've received great support from the industry, and we are happy to be back for another year. I'll be joined here shortly by Lars Strong, Senior Engineer and Company Science Officer here at Upside Technologies, and Tracy Collins, Vice President of Sales for the Americas at EchoSense, who will be headlining today's webinar to discuss how artificial intelligence and machine learning can optimize data center performance. Now, before I pass it off, I'd like to go over a couple housekeeping items. Everyone will be muted throughout the duration of the webinar, but we do encourage you to ask as many questions as you'd like, and you can do so using the Q&A module located in your Zoom dashboard. If you happen to have any technical difficulties throughout the duration of the webinar, please feel free to shoot me a message using the chat module, and I will try my best to resolve those difficulties as quickly as possible. Now, as I mentioned, this is week 2 of our annual Airflow Management Awareness Month. In week 1, we were joined by Lars Strong, who gave a very informative presentation on data center containment best practices and what to consider to maximize ROI. If you happen to miss that presentation, shoot me a message in the chat, and I can provide you with the link to where you can watch that on demand. Next week, we'll be joined by Mark Acton, Independent Consultant and Non-Executive Director at EchoSense, who will discuss data center risk management and the importance of mitigating risk to maximize resiliency. And lastly, but certainly not least, in week 4, we'll be joined by Bill Clayman, Executive Vice President of Digital Solutions at Switch, who will discuss how modernization and new digital demands have impacted and changed the data center. If you haven't already registered for those sessions, we'll be providing a link later in the webinar for you to do so if you'd like. Now, without further ado, I'll pass it off to Lars and Tracy to get us started.
Thank you very much, Isaac. Well, I've been in the data center industry for nearly 25 years now, and the trends that have been the most consistent have been this gap between IT and facilities, as well as a lack of cooling optimization, leaving money on the table. The data center not being as efficient as it could be, which affects both the effectiveness of the cooling, as well as the cooling capacity, ride through. It just has a number of rippling effects. And so I'm very happy you've taken the time to join us today. Really excited to talk about this and share what Tracy and I know about the application of machine learning and artificial intelligence to this new aspect of data center operations. Tracy?
Great. Thanks, Lars, and great to share the stage with you once again. And to everybody that's taken the time to join us today, appreciate it. Hope you get great value out of the session, and look forward to speaking with you in the future if you have any questions or need further information. So a little bit about my background. I run the Americas for EchoSense, and I joined the company a year ago. At EchoSense, we've developed an AI machine learning-based software platform, and it helps operators leverage data to operate their data centers more efficiently. Prior to EchoSense, I was the CEO of Simple Helix, which is a regional colocation provider based in Huntsville, Alabama. And prior to that, I spent almost 22 years with what's now called Vertiv, which is one of the largest providers of critical infrastructure to the data center space on the planet. In the last 4 years I was with Vertiv, I ran the IT solutions business for North America. So what does all that mean? It means I've spent my entire career in the data center space, both on the supplier side and the operator side. And I'll kind of echo what Lars said. Throughout that journey, I've watched firsthand as operators have continued to struggle between the efficiently balancing the relationship between critical infrastructure and IT load, and doing so in a manner that works on an ongoing basis. So I think this topic is great because AI and machine learning is bringing a new dimension to how you do that and how you go about it. And it's really changing the game for data center operators. Next slide, please. So with that in mind, we've put together what we think is a very robust agenda for you. We're going to talk about why data centers matter and some interesting stats around them, different categories of tool sets, how they're all valuable, and also how this newer category is different. We'll talk about the current state of optimization with the data center and why collecting granular data matters, how AI and machine learning solves the inherent big data challenges. We'll speak to the business side, talk about the financial picture. We'll look specifically at the time to value and ROI as key measures. We're then going to back that up by looking in some detail at 4 customer case studies that have deployed this type of technology. And then we'll wrap it up sharing our thoughts and summarizing why we believe that this approach will become the standard over the next few years and how data centers are operated. Next slide, please. So some of the data behind operating data centers. Now, before I talk stats, let's level set on a few things. First, purpose of the data center is to support the infrastructure that's required to power all the technology that we rely on personally and professionally. And it's easy to say, but let's think about that. Everything that we do in technology these days, personally and professionally, it all ties back to a data center somewhere. It's everything. So the challenge, and it's not a new challenge, is how do you plan for something that's going to start operating 12 to 36 months after you begin the process of planning and building it, before you put the IT load on it, and then you plan to operate it for over 20 years? How do you stay synced throughout that process? How do you plan for and then actually balance the requirements of the IT load with the critical infrastructure that it supports? Because there's only 2 constants if you're in the data center space, and that is change and the unexpected. And that's from things like platforms to equipment design, to the topology of what's going in there, the power density requirements, the associated cooling requirements. I think y'all get the picture. It all changes, it all, the unexpected becomes the norm, and then just as it normalizes, the new unexpected comes in. It's all very, very challenging to keep up with when it comes to the physicality of a data center and how you operate it. The traditional approach has not relied on data and data analytics, but rather it's based on operator experience and trusting that your assumptions are correct. And what has that resulted in? In many cases, the environment is sub-optimized. There's more risk than necessary. Operating costs are higher than necessary because data isn't at the core of how we operate our data centers. The first priority of a data center operator is always availability, right? They strive for 100% uptime with high customer satisfaction, which means that it's performing at a level that serves the customer's needs and expectations, both internal and external. The second priority is efficiency. This is things like using as little energy as possible and therefore lowering the emissions, keeping operating costs to a minimum. The trick, though, is that efficiency priority, that second priority, can never be implemented if it adds risk to the first priority. You can't sacrifice availability and performance for efficiency. Now, the good news is I think you'll come out of this session understanding that the balance between those two becomes aligned when you add AI and machine learning, because it uses the data analytics to simultaneously uncover and reduce the risk profile and improve the operating efficiency in the process. So the trade-off goes away. So let's talk about some of the stats that support that. First one, and ironically, I read something last night that said it's 2% now, but 1% of all the electricity used on the planet is consumed by data centers. The most conservative projections show the data center space and data center builds growing at 5% annually. And many think that is underestimating the growth that's going on. And certainly what we've been seeing in recent times suggests that. So what does that mean? It means it's already big and it's only getting bigger. And the trend isn't going to go away because the drivers that are leading to the growth And what are some of those things, right? Well, increased data associated with video, storage, compute, and that's everything from the smartphones that we rely on to the server and storage systems in the back end and everything in between. And that's the things we interact with. IoT ensures that just about everything out there is going to become smart and connected, right? Whether that's refrigerators or systems in your houses, everywhere out there, intelligence layer is building. And all of that requires infrastructure, requires data to support it, all of those things. It's driving the 5G network rollouts and everything associated with that. And we know it's only a matter of time before we're talking about the 6G rollouts, because before we had 5G, the big thing was 4G. So all of this insatiable increase, while the rate of increase may change over time, it's only going to ever go up. Nothing will reverse that. Next slide, please. 35% of the energy used in a data center goes to cooling the equipment in the data center. The Uptime Institute estimated that in 2020, 150 billion kilowatt hours were wasted globally by data center operators because of inefficient cooling and airflow management. For the operators, that translates to $18 billion in unnecessary costs. In operating data centers, research shows that 15% of the racks in an average data center are outside of the operator's target compliance range, whether that's ASHRAE or other. A third of the unplanned data center outages are caused by thermal issues. So it's big, it's addressable, and it's worth addressing. And that's the main thing we want you to get out of this. The technology now exists to change the paradigm in how these data centers are operated. And that's what we're going to talk about today. Next slide, please. So we've heard a lot about AI and machine learning all over the place. I mean, the reality is it's everywhere. Sadly, if you look at the operations of data centers, this is a space that's lagged when it comes to the adoption of AI and machine learning to improve the way that they are operated. And as a result, those data centers have operated less efficiently than they're capable of. It's ironic, but as data center operators, when it comes to the way we operate data centers, we actually, for the most part, abhor data. We try to stay away from it. And that's funny because we're in the data center business dealing with data, but we don't use it for the way we operate. And the biggest reason is because it's mostly noise to us. We've had to try to solve the data that's available with the human element, and we don't have enough people, we don't have the resources, we don't have the compute with between our ears to deal with that data, so it's better to almost ignore it. And the good news is that goes away now. AI and machine learning takes a big data opportunity, translates it for you, prescribes it for you, and allows you to experience things like lowering the risk profile, lowering your energy consumption, lowering your carbon emissions, lowering your operating costs, eliminating the trade-offs of risk to efficiency and aligning them. And all of this empowering the data, the decision makers and operators to remove the risk and waste associated with making assumptions in their approach by putting data at the forefront and real-time visibility to the results. So a very exciting time in our space. This impact is material, and it's important to note that implementing this type of solution, you experience the benefits and the improvements within weeks of deployment. Next slide, please. So there's lots of tool sets out there. Having tool sets in a data center isn't new. And you might ask, well, how is this different? And the main message here is that it is different. It's not replacing necessarily other tool sets, but it's addressing things that they don't. So we've got, as data center operators, things at our fingertips that we use, some or all, things like building management systems, energy management systems, or EPMS. We do CFD studies and leverage CFD software at times to do what-if analysis. We've relied on DSIM and the traditional asset management to understand what we have in our data center. Where the gap has been is the real-time analytics side, leveraging an AI and machine learning platform. That's the newest area of tool sets within the data center. This new category of doing it real time adds optimization to the traditional monitoring side. So if we look at this checklist, first thing I want to do is point out that I don't want you to misunderstand what the red X's mean. This slide isn't about saying that these other systems aren't good and don't add value, but rather it's focusing, if you look at the criteria down the left side, it's focusing on the things that they're really not purposely built to address that real-time AI machine learning based system does. So the message here is not that, hey, look at the thing with all the green check marks, it's better than all the things with the X's, but rather those things down the left are things that are now addressable that these other systems really weren't purposely built to address. So by collecting data at a granular level, looking at it at, say, every 5 minutes, AI and machine learning allows the operators to see what is happening. Well, that's not new, but what it adds to the mix is why it's happening and what you should do about it. That are the new elements that the AI machine learning brings to the table. It's not just seeing something's happening, understanding it and addressing it in the most efficient manner possible. So these types of systems allow for improved optimization of the environment, predictive failure indicators, releasing stranded capacity around the critical infrastructure are all benefits that this area brings to the table. Next slide, and with that, I'm going to turn it over to Lars.
Thank you, Tracy. So let's start looking at how this applies to, the actual operations of a computer room and in the space. So very few data center operators have real-time visibility to what's going on with the temperatures and relative humidities at the racks, at the intake temperature, at the intakes of all the IT equipment. ASHRAE has worked really hard to help guide the industry. And they've said that it is the data center operator's responsibility to provide the right intake temperature conditions at the face of the IT equipment. And it's the IT equipment manufacturer's responsibility to keep their equipment cool if those conditions are provided. But what happens is that there's very little granular data. There's very little information about in most data centers. While the temperature at the what's most common is monitoring the temperature and relative humidity at the cooling unit locations, and probably a few temperature sensors deployed out throughout the room. In the worst case, just on columns or walls, but often on a few of the cabinets. And then the hope is that that will give them an idea of what's going on, in all the racks. And it doesn't work that way. The temperatures within racks can vary greatly, and just because one rack is happy doesn't mean the rack next to it is happy. And if the top of a cabinet has good intake temperatures, it doesn't mean the bottom is. So there's a lack of visibility. And this lack of visibility, results in inefficiency in areas of the room being too cool and areas of the room being too hot. When you have excessive heat, that affects the server performance and the useful life of the equipment. The server fans run faster, consuming more energy. And then when you're overcooling, obviously you're wasting capacity in an area of the room that doesn't need that much cooling capacity. It increases humidity levels. And all of this negatively impacts, the goal of operating the facility. Next slide. So the application of AI and machine learning has been applied to optimizing compute, storage, virtualization, and networking at the software layer for years. And the efficiencies are realized every day. But when it comes to operating the data centers themselves, the critical infrastructure, space, power, and cooling, to the IT load, that's where AI and machine learning has not yet reached even the early adopter stage. We'll show you some cases that case studies towards the end that did explore this. It's been around for a while. It's gaining traction, but we're still very early in the process of realizing the benefits that can come from this this technology. The emphasis continues to be on designing to an anticipated requirements. Tracy covered this quite a bit as he did his intro. We design data centers for a average watts per square foot and figure out how many cooling units we need given the total load and what the rack densities are going to be, but it rarely works out that way. The plan looks good on paper, but then reality strikes.
It's funny, Lars. This challenge that you're describing reminds me of something that the great philosopher Mike Tyson famously said, and that is that everybody has a plan until they get punched in the mouth. For anybody who's been in the data center space and involved in the operations, they know exactly what we're talking about.
Yeah, absolutely. I mean, one of the greatest, most extreme examples of that I've heard of is a very extensive business case was done to justify a $20 million IT purchase. And it showed up on the dock to the surprise of the facilities people, and the realization was that there wasn't enough power and cooling to support the IT purchase. So a great deal of remodeling had to be done, upgrading had to be done to accommodate it. It can be really bad. Hopefully that's the worst case that's out there. So let's talk about what we do and how this can be applied. So the first step is gathering data and gathering granular data so that we can actually see what's going on. And this can be an eye-opening experience to see what the temperature profile is of every rack in the room and of every cooling unit in the room. And then as well as the layers of power consumption and power consumption throughout the room. And, you see in this picture, this is before optimization occurs, that there's some cold areas of the room, there's some warm areas of the room, there's some areas that are okay. This is quite typical. The goal of cooling optimization, of course, is to have everything even, uniform, and consistent. And that's often not the case. So, the first step when we start collecting this data is to realize we do have a problem. And we can go to the next slide and start to capture this data in real time and apply these tools to apply these machine learning and artificial intelligence tools to very complex data sets and start to identify patterns that are very difficult to identify without these tools. One of the really nice features is the ability to identify the airflow patterns underneath the floor. This image is showing you the zones of influence, and each of the cooling units is a particular color, and each of the cabinets is a color that matches the color of the cooling unit that cabinet got its air from. And so the software is able to compare variations in supply temperature from the cooling units with variations in intake temperature at the IT cabinets and find out where the air came from. And you may or may not realize that the air underneath the raised floor doesn't mix very much, actually. Each cooling unit has its own unique plume, and those plumes of air bump up against plumes from other cooling units, and there is a distinct boundary layer. You can see in the right-hand side of this slide that there is an infrared image that I took in a data center, and it shows a 5-degree difference in the supply temperature of air coming out of one corner of a supply tile versus the other corner of a supply tile. And that's because there was a 5-degree difference in the temperature of the air coming from two adjacent cooling units. and that air was bumping into each other and not mixing. So this becomes really useful in identifying things like where is there redundant capacity and how do we make adjustments that actually make a good impact in the room. Because quite often data center operators, with good intentions are making adjustments to set points and controls, but they're doing it to the wrong cooling unit. You're adjusting the wrong parameter because you don't know what's actually happening in the computer room. So great insights can be realized, and the visuals make it just very, very clear. So continuing on, this is what happens with the application of the optimization. And that's a unique feature of these tools, is that they can pay attention to this data, look at trends, and then provide recommendations. There are a number of people in the industry that have had a lot of experience with optimizing data centers, and some very smart people can write very extensive algorithms to identify trends and patterns and say, okay, well, telling the software, what do we do when we identify and we see a particular condition? And so the operators get engaged in the process, they get the recommendations from the software, and they can make adjustments to get everything even and stable and consistent. And in a lot of cases, warmed up a little bit and closer to that upper range of the ASHRAE recommendations. So let's go into the steps and the process that actually occurs in this application. There's 5 key steps, and it's gathering accurate cooling power and space data, making it quick and easy to visualize, applying the tools of the analytics, doing the optimization, and then continuing this on an ongoing basis. And now we'll start to look at each of these in a little more detail. So when you consider gathering, I've said it before, but granular data makes this really powerful. Since we're using computers now, we can gather a lot of data. That's been one of the criticisms of the rise of DSIM, is that it provides a lot of data, but not a lot of action. It provides a lot of information, and it's hard for data center operators to sort through that and know what to do with it. This is a way to make sense of that data and create actionable results. Gather that granular data and then visualize it. As you see on the next slide, we need to provide graphical information about what's going on. I've been in a number of computer rooms that have deployed these tools, and what happens is that a screen like you see here on the right is the primary main screen in the NOC. It's the one that you can walk by and at a glance see what's going on. And hopefully this isn't what the computer room looks like, the temperature profile. It would be, this is the pre-optimized version, but it would be that post-optimized version, and it allows people to very quickly see what's going on. And then, behind just this view of the computer room, there are a lot of very quick to understand historical graphs and trends and intuitive information that can be gathered and represented through reporting. Analyzing it, sharing that information in very detailed ways. You can go in and see trends about what's going on. And one of the things that stands out to me as I do talks around the world on cooling optimization is that everybody knows how many tons of cooling they have installed in the data center, but nobody knows, or very, very few people know, how much cooling is actually being delivered by each of their cooling units. So that kind of analysis can be very easily done and represented in a very clear format. And then, as I've talked about, the optimization process, this is key. And this is where the software provides actionable recommendations to the operators. there are a couple of different approaches. The approach that EchoSense has taken, and in these examples, that's primarily what we're talking about, because that's where we have our most experience with these tools is with that solution. But I'll talk about what Google has done later on in the presentation. The EchoSense solution provides recommendations. It doesn't actually control anything in the facility. So it engages the site personnel in the process of optimizing temperature set points, adjusting the floor grills, changing the cooling unit fan speeds, and even suggesting recommendations for rack placement, where analyzing and identifying where there is redundant cooling capacity in the room, and where a new deployment can be supported. And this is all done, in real time and updated every few minutes. Hundreds of thousands of data points can be collected, per day and analyzed by these systems. And the key to this is ongoing. It's possible for any individual with, some experience in this field to walk into a data center. I've done this many times, go in and take a bunch of measurements and provide a lot of recommendations, make adjustments, rearrange set points, rearrange supply tiles, get the room optimized, but then it drifts, and over time, all of those benefits fade away because of the change that occurs in the data center. This graph shows that when you deploy these tools and you start making changes, you get huge benefits. You get huge return on those changes very quickly. That's really nice because it really helps with the simple payback of deploying these tools. But what's really important is the right side of this graph, and that's maintaining those benefits in perpetuity, making sure that the data center doesn't drift out of efficiency, as I mentioned, making sure that as significant add moves or changes occur, that everything is being adjusted to make sure that the least amount of energy being consumed, is being consumed to keep the IT equipment happy. Tracy mentioned that in a typical data center, 35% of the energy being consumed is going to cooling, and that's 35% of the total load going into the facility. And the math turns out that it's somewhere around 73% of the non-IT load. So if you just say, take away what's going to the IT equipment, you just say, okay, of the other power, how much is going to cooling? And it's like 73/4 of the power. So a huge point of leverage in optimizing the cooling in these facilities. All right, so Tracy, want to continue?
Yeah, thanks, Lars. So to kind of expound upon what Lars was just talking about, let's look a little bit at the business side. So the time to value and the ROI. Unlike your DSIM and traditional monitoring solutions, implementing an AI and machine learning based system is different. Doesn't mean it's better or worse, it's just different. How is it different? An AI machine learning based system, an installation can be completed in days. You have a 500 rack data center. It'll be instrumented and up and running the same week that the implementation starts. Then the initial optimization takes place. It can, within days, typically it's usually a week or two, to let the AI and machine learning learn the environment, go through the different cycles and figure out and see what's going on. But you'll start seeing right away because it presents all of that information very, very graphically. Once that implementation is done and you've started optimizing it, you start realizing those benefits right away. So literally within a few weeks of first deploying the solution and getting it up and running, the benefits that Lars showed on the last side, that left side, you start experiencing them right away. There is a direct measurable payback in ROI associated with the energy reduction, energy consumption reduction that you'll experience. So as the system finds the imbalances and the inefficiencies and shows you how to correct them, the byproduct is you're going to consume less energy. So Many customers actually get a payback of less than 12 months when they stand up this kind of solution. These solutions also, virtually every utility provider out there offers subsidies for energy reducing initiatives at accounts. This category of solution is typically eligible for those types of rebates, meaning that you can actually get your utility provider to help offset the initial costs of implementing the solution to begin with. And the overhead to operate them is minimal to non-existent. What I mean by that is you're not hiring people to manage this kind of system. Implementation is straightforward. And in fact, what you're doing is you are allowing the staff that you already have in place to be empowered with data and all the analytics done for them. Take that crunching off of their plate and let them focus on action and results. So you actually bring more efficiency and shift around some of the process and workload that the existing team has without having to add any additional bodies to the mix. Next slide, please. So why does AI and machine learning matter in the data center? Well, I want you to go on a journey with me. So I'd like everybody to close your eyes for a second. You too, Steve. I can see you're still peeking. Now I want you to imagine a scenario. Imagine a solution that allows you to lower the risks that you have in your data center, reduces your energy consumption, reduces the carbon emissions as a result, allows you to release stranded capacity of your critical infrastructure systems, can actually start to predict failures and failure states before they occur. All of this while lowering your operating costs associated with running that facility. It allows your teams to make data-based decisions and for them to see the results of those decisions real time to understand the impact. All of this implemented within a period of a few weeks within a facility. You can open your eyes now. Your company likely has some type of sustainability initiative in place or under development. And if you're like most companies, it probably has the words 2030 or even 2035 in the descriptor of it. Those programs are typically tied to new builds, massive capital upgrades and replacements, all fantastic things, but they take years to plan and implement. This type of system can be implemented in 2022 and the benefits realized. So what you can do is enhance your program to speak around the 2022 and beyond component of your 2035 sustainability initiative or your 2030 net neutral program, whatever flavor of name that you've got applied to it. It almost seems like it's too good to be true, but it's not. This is real. Companies are doing this. The challenge has simply been that people haven't been aware that this is possible and that this is available. So now with that in mind, let's talk about some of the companies that have deployed this type of technology. So the first case study we're going to look at is Interaction, which is a division of Digital Realty in Europe. Prior to implementing a AI machine learning based system and approach to managing the data centers, they were relying on their BMS system, and which was providing great value to their business. But what it wasn't doing was reporting any issues, even though there were issues. It was simply blind to the issues because it lacked the granular data and the ability to analyze at a level that is necessary. So the client implemented an AI machine learning based solution, and the solution was immediately able to detect the issues, was able to determine and isolate the root cause and help the customer understand this is happening and why, and prescribed steps to remedy, literally lists out actions to take, allowing the operator to implement those actions and see the results and watch the transformation in the performance of the facility. It allowed them to identify setting changes that allowed them to increase their free air window. And so that brought more efficiency, lowered their costs, and allowed them to use green energy a higher percentage of the time as a result. They continue to use the system to monitor and counter all of the issues that can create drift. And Lars talked about that a little bit in his section. You know, the two biggest things that cause drift in a data center, drift means things that are aligned and optimized separate over time. Number one, human induced issues, right? Things like when we go and do maintenance and tests and so forth, the people that go in and do that work don't always restore back to the proper settings. They make changes and they undo things that are in place. The system starts seeing a lag in performance as a result. Time correlates that to when those actions took place and allows companies to go in and in this case, undo the, for lack of a better term, damage that people have done. And the other is environmental changes that changes the environment as well. The IT load changes, spaces that were empty get filled, spaces that had a certain density get replaced with new equipment that has a different density. And all of that changes the behavior of the environment, and the associated infrastructure that's providing the power and cooling to it is impacted. So the net result that they experienced was they went from an environment where they had a lot of racks outside of their compliance range to 100% thermal compliance. In that process, right out the gate, within weeks, they were able to reduce their cooling energy consumption by 21%. And in the 12 months that followed that, they reduced their energy bill by $175,000, and that compounds annually. They're now operating more efficiently, and they're saving that kind of utility bill cost on an annual basis. Now I'll turn it over to Lars to talk about the next case study.
Thank you, Tracy. So this one is for O2 Data Centers, a telecom company, and they deployed the EchoSense solution across 12 of their sites. And so what's significant about this is that this is data from all 12 sites. You see in this graph at the bottom, this colored graph with the two columns before and after, each of those colors represents a different site. And you can see that they have a variety of loads, variety of different scales to the data centers. The other thing that's significant about this is that they have a variety of these 12 sites. There's a wide variety of vintages of infrastructure and tier level design. And we can see that you can look at some of those bars and see the reduction in the energy consumption. You know, the bottom blue bar gets significantly smaller. A couple up, that yellow bar gets significantly smaller in the after conditions. The dark blue above that, which is one of their larger sites, got significantly smaller. So over a wide range of different sizes and sophistications, and obviously a wide range of PUEs in the existing condition, they saw an average of 19% reduction in their cooling energy. And that resulted in nearly $1 million of annualized savings. And not to be left unsaid, 1 million kilograms of CO2 saved per year. So very significant improvements. And one of the things you can do when you look at all these data is you can apply that energy savings to regain stranded capacity. Is another spin on this, which is that with the recovery of, or with that energy savings, means you have recovered stranded capacity that can be used for cooling additional load, particularly valuable to, well, everybody in the data center industry, but obviously for colos as well, making sure they can cool all the customers and cool what they've sold. So just a really important aspect of this process.
Great, Lars. certainly another good example of material change and impact that's good for the operator, the planet, and the customers that they serve. Next case study is a global insurance provider. This study is, in this case, what we're going to show is similar to the others, but also how the system impacted over time the operation of the data center and actually led to a decision being made on upgrading the cooling systems that they were using. So, you know, the before and after shots you see on the top, the left and right, but beneath that you see bar graph, and what that's showing is quarterly from the benchmark starting on the left to the improvements right after benchmark, that post optimization through a quarterly approach that they use to ongoing optimization, to a decision being made to upgrade the cooling infrastructure. So let's talk about a little bit about their environment. So not dissimilar from the last example I talked about, prior to implementing this type of technology, they were relying on their BMS, and the BMS was not able to identify warm zones or to recognize that units were actually recirculating warm air. And as a result, when that happens in a data center, and all of you that are, you know, on the mechanical side know, when you have that kind of problem, the cooling units that are adjacent try to compensate. Unfortunately, because of the way plumes of airflow works and everything else, as Lars talked about, they actually, sometimes that process does more damage than good, and it leads to overcooling while not really addressing the heat areas. So it creates more imbalance and more inefficiency. They deployed the AI machine learning based system, and they were able to, you know, within the first few weeks, achieve 100% thermal compliance. They reduced their energy consumption by 23%. In that environment, that size, that translated to a $70,000 reduction in their utility bill annually. And it's important to note, those benefits that I just listed, they experienced all of them within 4 weeks of first implementing the system. That benefits were that fast. The client implemented a quarterly optimization program to leverage the system with the goal of continuing to look for improvements and efficiencies and squeeze them out. So as you can see, while the big benefit is right up front, and that's awesome, there are more benefits over time, and it keeps the reverse trend from occurring, the drift that we've alluded to from taking place. So they were able to get the maximum efficiency out of their environment, and they got to the point where they felt they'd done as much as they could with what they had, but they wanted to do something different. So they actually took the data to the executive organization and said, we want to implement, we want to do a hardware upgrade. We want to put in a free air cooling based system that can leverage free cooling and the efficiencies and everything associated with that. They implemented that, and that's the green bar you see to the right. That's where their efficiency went after implementing that kind of solution, while maintaining balance throughout. So you look at where they started with the benchmark, the efficiencies they gained just better using what they've got, and then a decision, we can put better things in than we've already got. And the beauty is the system shows all of this throughout the life cycle. The executives can see the performance throughout that time. They can see the energy consumption data as it changes over time. The balance is there. Any events that do take place, they have full visibility and timeline and time stamping of all of that. Everything that is happening in the system is all captured and maintained within the database and readily available graphically, and charts and graphs and so forth. So in this case, it became the way they operated their data center more efficiently and drove the decisions, and were able to go back to management and say, and here's what it looks like as a result, which we all know as data center operators, management above and outside of the data center often says, you guys are a black hole. I keep throwing money into it and I don't know if I'm getting a return. They can show their leadership. We got a return on these decisions. They were justified. Now I'll turn it back to Lars for the next case study.
Thank you, Tracy. The last case study we have to share with you is for Google. While the application of the machine learning and artificial intelligence is new to the data center, is still in the early adopter phase. This process was started some time ago. In 2016, Google and DeepMind jointly developed an AI-powered recommendation system, and they applied that to their already very highly optimized data centers. You know, we've all held and known Google to be, you know, one of the ones with the lowest PUEs. And so it's remarkable that even though they had already, you know, been doing things really well, they were able to get these results of 40% reduction in cooling energy, a 15% reduction in overall PUE, and 3.5 times more computing power with the same amount of energy. So these results really show how profound these solutions can be. The original deployment of this system was a recommendations system, and that means that the software was not making any changes. They are experimenting now with having the software make changes in their facility. That's what I mentioned earlier in the presentation about there's a couple of different approaches, but they've acknowledged that when they do that, they're gonna dial back the recommendations so that there's less chance of something going awry. You want to make sure that any changes if you hand over the controls to the software, that it's not going to make a mistake. So pluses and minuses on both sides. But again, what stands out for me about this case study is how much benefit a facility that was already very efficient was able to achieve.
Thanks, Lars. So wrapping up, we believe that this is becoming the new standard in data centers, and it's across all segments. As Lars just mentioned, what Google's doing and the hyperscalers are looking at to achieve a next generation efficiency level by leveraging AI and machine learning. Co-location providers have started rolling this out. Enterprise data center operators, the telco companies, large lab environments that are maybe non-production but have the same behavioral characteristics of data centers and an even greater rate of change. They're all implementing these kinds of solutions. It brings data to the forefront. It's becoming the standard, and because as a result, operators benefit by removing thermal and power risk, reducing cooling energy consumption and those costs by an average of 30%, reducing the associated carbon emissions, releasing stranded capacity on the critical infrastructure to support IT load, which means being able to support more IT load without having to upgrade or increase the investment in the cooling infrastructure and IT infrastructure. All of this while providing the operators the ability to leverage data to drive their decisions and real-time visibility to what is happening. Implemented within weeks, payback that is often less than 12 months. So the word's getting out and the adoption is accelerating. In fact, we believe that within the next 3 to 5 years, data centers that are not leveraging AI and machine learning will be the exception, whereas today they're the rule. So that wraps up our presentation. I'll now turn it back to Isaac, and we'll do the Q&A session.
All right, great job, Tracy and Lars. First and foremost, I did want to let everyone know that this presentation is being recorded, and we will share the recording as well as the presentation slides with you within the next couple of days. All right, let's jump into the question. So we had one that was asked during the cooling zones of influence that you were talking about, Lars. And Andre wants to know, can these patterns be predetermined during design? This would be critical in fan coil placement.
The answer to that is yes, with a theoretical deployment of IT load and the associated supply tiles necessary to support that load. But what might actually end up needing to be the configuration in the computer room once it's operational is likely to be slightly different. So that's where CFD analysis is useful, is in the evaluation of theoretical designs. These solutions that we've been talking about today don't work on the theoretical design of facilities. They work on real-time data, what's currently going on, and what trends have been occurring in the different components over time. That's how they work. So these tools would not be able to do that. CFD would be able to, but it would have some limited application.
Yeah, the only thing I'll add there
Thank you, Lars.
is it's an example of the very complementary nature, and I described the different tool sets that are out there. There are modeling solutions that are available. While you can do, once you're operating it, you can do some what if scenarios and start putting some load to leverage a tool that is based on live data and granular data before any data is available is not really the primary function of a system like this.
Great. Thank you. Thank you, Tracy and Lars. Brian wants to know, what is the licensing structure for this product service? And looks like he had a follow-up question. Is there a selection of AI models reflecting different optimization levels possible?
Okay, so let me tackle the first. So if we're talking EchoSense, we are a SaaS solution with a annual license charge. We're not like your traditional you license the software, you buy the software, and then you pay maintenance fees. You just pay an annual fee throughout the operation of it. Although we are flexible in the way we structure contracts with customers depending on availability of CapEx and OpEx budgets. But that is how it works. It is not a perpetual license model, but a subscription model. The second question was, say it again so I'm clear.
Is there a selection of AI models reflecting different optimization levels possible?
I don't know that I fully understand the question, but let me share some thoughts, and then Lars, if you've got any additional, by all means. The AI, you get to control the parameters when it comes to, for example, the ranges that you want on temperatures and humidity. You get to control all of that, so it will measure against what you choose. So whether you choose standard ASHRAE or you've got something different, you're flexible there. As far as the AI algorithms and how it's measuring everything, no, it takes all of the inputs that are available and correlates against that data. But there is no, you can't change the algorithm or the way it operates. You can just change the parameters that it is scoring against. And I'm not sure if that answers the question or not.
Yeah, we'll be able to follow up
Thanks.
with anybody afterwards. If anybody would like to go into more detail, we're happy to have those conversations offline.
Absolutely.
All right, let's go on to the next one. Can existing DMS or EPMS use for the AI ML, or do we have to add other sensors need to add for the more effective solutions?
So I think the question was, can we leverage sensors that are already deployed? And if that is the question, the answer is yes, we certainly can. So the system is about ingesting live data. It's not about ingesting live data that come from just our sensors. So if you've got rack sensors that are in there, typically what we find is the client doesn't have the density that is required, because we want to put a sensor on every cabinet. Preferably two, but the AI machine learning requires one on the inlet at about the 5-foot level. So if you've already got like sensors every third rack, for example, is not uncommon. We can pull those in to the system and then augment either with more of those sensors or sensors that we've developed.
Got it. Thank you, Tracy. And we'll ask one more before we wrap up here. Monitoring temperatures and humidity in the data center isn't new. Can you expand on what makes this different?
Yeah, so I think we talked about that in a few stages in the presentation, but the main thing is you're exactly right. Monitoring and the availability of lots of data isn't new. now being able to get excited about doing something with that data, and in fact increasing the data collection rate to go from sampling to full environment, it all changes because AI and machine learning takes that data and cuts through all of it for you and allows you to understand how to turn noise, data from noise into actionable steps. So historically, we've not wanted that data because what am I supposed to do with it? I'm seeing a bunch of things. Just tell me if there's a problem. If a temperature is breached, send me an alert. Well, wouldn't you rather optimize the environment and get it balanced first? And AI and machine learning changes all of that because it brings data to the forefront and allows you to add, if you remember, I talked about not just what is happening, but why and what you can do about it and all of the benefits associated. That's what bringing the optimization to monitoring does for a data center operator.
Got it. Thank you, Tracy. We are out of time here. We do have a couple other questions that are being asked, but I think we're going to have to follow up after the presentation. We are about 3 minutes over now. But Lars and Tracy, thank you so much for a great presentation. Thank you all to all of our attendees for joining our presentation. We really appreciate your support, and we will follow up with the questions that we didn't get to after the presentation. Thank you so much.
Thanks,
Bye,
Isaac.
everyone.
Thanks.
Thank you.
Appreciate everybody's time.